Hello.
Hi, sir.
Hello. How are you?
Fine, sir. How are you?
Good. Okay. So let's just start now. Everyone is good? Tell me, all of you are fine?
Yes,
Yes,
sir.
sir.
Okay. Did you solve the questions? What was given in
Not all,
electrostatics?
sir, but still solving.
Yes, sir.
Around how many? 50 questions were there, isn't it?
Yes, sir.
Yes.
So before the next electrostatic class, complete all those questions. Okay.
Okay, sir.
Okay. And after today's class, uh, vector addition, subtraction, those questions you can do it. Okay. Already I have given the question on the addition, subtraction, and the component taking. Okay, so today we are going to start with the uh, position vector and displacement part. Okay, vector product is there. Vector product will be useful in the work energy chapter. Once the dot product will be useful, and when we will be calculating the torque. Okay, in the rotation chapter, there we will need the cross product use. Okay, so now we are going to start with the uh, position vector, displacement vector, okay, na, velocity. So these kinematics thing we are going to start it with today's class. Okay, please tell me. So when the dot product will be needed in the work energy chapter, so that time I will discuss with you the dot product. Okay, please tell me. Everyone clear?
Yes, sir.
Yes, sir. Right. So let's just start now. Are you able to solve the questions? What was given in the electrostatics as the homework?
Yes, sir.
Okay. So let's start from here. Okay. So in the mechanics part, we were in the scalar and vector quantity we have divided. Okay. Next, different type of vectors we had, right? Then we had unit vector. Then how do we calculate the magnitude of vector? Okay. After that, we had what? The subtraction of vector as well. Unit vector. That is the most important part here, isn't it? In the vector, most of the questions, most of the vectors you will find out written in the unit vector form. Okay, which form? Unit vector form, right? So unit vector along x, y, and z axis we had it as I, j, and k cap. Okay. So if the vector is given in the unit vector form, what we can do it? We can add the component wise, isn't it? I cap component with I cap, j cap component with j cap, and same thing we can do it for the k cap component. Sometime a vector is given and then they are asking us to find the unit vector of that one. How do we find out the unit vector of that one? By taking the vector divided by its magnitude. Okay. Yeah, mod of the vector. Mod of the vector means what? The magnitude of the vector. Okay. And then what we discussed, the component of vector or resolution of vector. Component of vector is also called as what? The resolution of the vector. So the two most important things from the vector chapter we have, which we have so much use later in the kinematics, NLM, work energy chapter, or throughout the physics chapter, are the vector in the component form. And the second thing we have is the how to take the component of a vector. Okay, right? So let's just start with the now position vector and then we will enter the kinematics part. Okay. Acha, all of you are writing the notes also after the class or not?
Yes, sir.
Yes, sir.
Yeah, please complete the notes. Although it is written in the PDF format, okay, which I'm sharing with you, but still write your own notes. Okay, because that will help you in understanding much better way. Okay, na? Instead of only looking at this class note, just write the notes by yourself also. Okay. So now tell me, what is the position vector? Tell me. So let's start the kinematics part now. Okay. Should we start dot product and cross product? We will discuss it when it will be needed in the work energy chapter and the talk chapter. Is that clear?
Yes, sir.
And when we will discuss the flux, electric flux, Gauss law, there also it will be required. So before we are going to discuss the question on that, I will discuss you that concept also. Okay.
Which one, sir?
So that dot product concept,
Okay, sir.
because the
So
electric
there is no dot product in vectors for us.
here it is not needed. Kinematics, NLM, friction, circular motion. In these topics now, dot product is not required. Dot
So
product is direct. Yeah, tell me.
when will you teach it to us?
In the work energy chapter,
Dot product. Okay, sir.
yes, dot product is required when the work energy starts. How to calculate the work done? Na? There the dot product starts. Okay,
Okay, sir.
right? So don't worry. Whenever you need any topic, any new topic comes in the uh, discussion of a topic, I will definitely discuss with you all those topics. Okay. Our focus should be the learning the entire chapter. Okay, na?
Yes, sir.
Right. So let's start with the kinematics now. Okay. So now in the kinematics, what we have kinematics, what we do, we discuss about what the motion of an object. Okay, motion of a particle. Is that clear? In the kinematics, what we discussed, we discuss about how a particle is moving, how much time the particle has taken to move certain distance. Is that clear? Tell me, is that clear? So, with the help of that, we can find out what will be the velocity, acceleration. These things we are able to calculate for a particle. Is that clear? So, kinematics is what? It is the learning about the motion of a particle. Okay. But the moment we call the motion of a particle, tell me, is the motion of a particle is something absolute? Can you say that this particle is at rest or this particle is in motion? Can you say with 100% surety? Tell me. Okay, let me ask a different question. I'm asking a question. There is a book kept in your car. Okay, there is a book kept in the car. Now, if you are sitting inside the car and you look at the book, is that book is at rest or moving?
Rest.
Rest.
Rest, right? But if someone is standing on the road and then he is looking at the book, what is that book is doing?
In motion.
That is in motion. The same book is there, but one person is telling it is at rest, and other person is telling what? It is in motion, isn't it? So that means, can I say that rest, an object is in rest or is in motion? That depends on what? Who is the observer? Is that
Yes,
clear?
sir. Frame.
Frame dependent, or in simple word we can say that observer dependent. A frame is nothing but an observer who is observing the motion of a particle. Is that clear? So can I
Yes, sir.
first write it here? Rest or motion of an object, rest or motion of an object depends on frame. Okay, frame of reference. In simple word, what you will call it? Frame of
Observer
reference,
depend.
or simply we can say that it depends on the observer, isn't it? Please tell me, rest or
Yes,
motion
sir.
of depends on the frame of reference, or we can say that that frame of reference is nothing but an observer. So, with respect to an observer, if a particle position is changing, can we say that that particle is in motion? And with respect to that observer, if particle position remain same throughout the time, then we will say that for that observer, it is what? It is in rest. Is that clear? So how do we decide about an observer? So the simplest form of an observer is what? Right? We have the coordinate axis with us, isn't it? X, Y, Z axis. So what we do, we keep an observer where? At the origin of the coordinate system. Let's say this is X, this is Y, Z axis is there. So what we do? We fix the observer where? We fix the observer where? At the origin of the coordinate system. This is the observer. Now, with respect to that observer, we are going to observe the motion of the particle. Is that clear? So now, let's say with respect to this observer, the particle is initially somewhere here. Let's say that is the initial position of the particle. So can I say that if this is the initial position of particle, so that means this vector, can I write it Ri? What will be this Ri? Can you tell me what is this Ri?
Position vector.
Position vector. So this vector represents the position of particle, okay? Let's say after some time the particle goes from here to here. So the new position vector will come, isn't it? Let's call this is the Rf. Okay. So now we are going to define the two things. What are the two things? We are going to define the displacement of the particle, and we are going to also define what is the distance traveled by the particle. Please tell me what we are going to define is the displacement of particle and the distance traveled by the particle. So first of all, tell me what is the displacement of a particle and what is the displacement, is a scalar quantity or vector quantity? Please tell
Scalar
me first.
quantity.
Displacement, I am asking.
Vector quantity.
Displacement is a vector quantity. Why? Because the displacement has magnitude as well as direction. So what does it mean by displacement? Displacement means what? Initial point and final point is known to us. If I can find out what is going to be the shortest distance between the initial and final point. What distance? The shortest distance between the initial and final point is going to be called as the displacement of the particle. So what can be the shortest distance between the 2 points? What can be the shortest distance between the 2 points? Can
Straight
I say?
line joining between.
Yes, it must be what? The straight line joining the initial and final point. And the direction of displacement vector is what? From initial towards what? The final position. Is that clear? Please tell me. So displacement can be written in many ways. What are those meaning of displacement? Sometimes it will be written, it is the shortest distance between the initial and final point. Or it is the straight line distance between what? Initial and final point. Or it is the change in position vector also can be written sometime. See that. Is this vector, if I write the symbol here, let's write it, this is O, this is P, and this is Q. So can you say that this PQ vector, what is this PQ vector here? Is this PQ vector is the displacement vector for us?
Yes, sir.
Please tell me, is this PQ is the displacement vector? Check it. Can you write PQ vector as OQ vector minus OP vector? I will just tell you how it is coming, okay? See, so what is the meaning of displacement? How can we write the displacement? It is the, can we write two, three ways? It is the shortest distance between
And
initial and final point, or initial and final position also you can write it. This is the one way to define the displacement. Okay. What is the other way to define the displacement? It is the straight line, because the shortest distance between any 2 points can be the straight line only, isn't it? So it is the straight line distance also we can write it, isn't it? Straight line distance between initial and final point. That is another way you can say that. or initial and final position. What else we can write it? It is also same thing. These all the three lines are same. It is also equal to change in position vector. Change in what? The position vector. We can say that. See that. Tell me, apply the triangle of vector addition. Check it. Can you write it OP vector plus PQ vector? Is that equal to OQ vector? Use the triangle of vector addition. See that? OP vector, first vector, PQ vector, second vector, OQ vector must be the resultant vector, isn't it? Check it. OP vector plus PQ vector can be write it. It's going to be OQ vector. So that means, what is this PQ vector? Is it OQ vector minus OP vector? Check the symbol. Is the OQ vector represents the final position vector? Minus. OP vector represents the initial position vector. See that? So is it clear about all the definition of what is the displacement? Please tell me.
Yes, sir.
So if you want to calculate the displacement of a particle, what you will do it? You will find the shortest distance between the two particles. Shortest distance between the initial and final position of the particle. That is the one way. Or you join the initial and final point by a straight line and just find the length of that straight line. That is going to give us the displacement. Or sometime position will be given in the vector form. Like this is my initial position vector. After some time the position vector is something else. Okay. Then with the help of what? Change in position vector also, we can find out the displacement of a particle. Please tell me, is that clear?
Yes, sir.
Yes, sir.
So this is about the displacement. Now, one theoretical question I'm going to ask you. Please tell me, is the displacement depends on the path followed by the particle? Is the displacement of a particle depends on path followed by the particle?
No, sir.
Please tell me. Is the distance between the particle is the displacement of a particle depends on what path particle has taken to go from initial to final point? Yes
No,
or
sir.
no?
No,
No,
sir.
it does not depend, right? So whatever path you want, you can choose it. Your displacement is always going to be equal. Why? Because the
Path
moment
independent quantity.
yes, because the moment I call displacement, that means I am sure about I am going to calculate the straight line. I may have followed any different path, but my displacement is also always going to be what? The straight line distance between the initial and final position. Is that clear? So that is about the displacement. Now, once we clear about the displacement, we have the next quantity that is called as what? The distance. Now, what is the distance? Tell me. A scalar or vector?
Scalar.
What is the distance of particle?
The actual path followed by a particle.
Yes, it is what? It is actual path length. Actual path length, path length covered by the particle, covered by particle to go from to go from one point to another point, okay, or one position to another position. Clear? So here is the path is important. Tell me, to calculate the distance, is the path is important. Please tell me how I went from point 1 to point 2. Is it also important in determining the distance traveled?
Yes, sir.
Right or not? So that's why distance is what? It is path dependent quantity. Is that clear? So now if
Yes.
I say, let's say I'm going from one point here, I, to another point F here. How many paths is possible?
Infinitely many.
Infinite path is possible. Someone will go like this. Someone will follow this path. Someone will go like this, and then it will come back to here, isn't it? So there are infinite path possible, and every different path gives me what? Different distance traveled by the particle, isn't it? But what is going to be same in all the, what is going to be same irrespective of the path is the displacement of the particle, isn't it? So can I write one thing? Please tell me if you all agree. Can I write it? Distance is always going to be greater or equal to magnitude of displacement? Please
Yes,
tell.
sir.
Can I write something like this? Distance is always going to be greater than or equal to the magnitude of displacement. Please tell. Is
Yes,
it
sir.
possible that the distance is smaller than the displacement magnitude?
No, sir.
Never possible, isn't it? Why? Because displacement is the straight line distance, right? Which will be the shortest one. So any other path other than the straight line I follow, think about it and tell me, if I follow any path other than the straight line, am I always going to get the more more distance travel compared to the displacement? So that's why just keep in mind this theoretical point, okay, that distance will be always greater than the magnitude of displacement. Clear? Distance and displacement cannot be compared. Can you compare distance and displacement?
Both are different type of quantity.
Yes, both are different type of quantity. One is a scalar, another one is a vector. So you cannot compare them, but can you compare their magnitude?
Yes, sir.
Right. That's why understood. Second thing,
Sir, can you
another
go a
theoret
little up? Little up.
here.
Till distance, till distance.
Check it here now.
Yeah, okay, now it's okay.
Right. So distance is what? Actual path length. Okay now. So tell me, distance is always going to be greater than what? Greater than the displacement of the particle. Now, a particle is moving, okay? A particle is moving. It has moved for some time interval, right? Now tell me, if a particle is traveling for some time, can I say its a displacement may be zero? Is it possible for displacement to become zero?
Yes, sir.
Yes, sir.
Right. Why and how?
Can come back to its initial position.
Very good. If the particle come back to its original point itself or initial point itself where it started its journey, so then I can say that displacement will become zero. So can I say for a moving particle, tell me this point for a moving particle, can you say that displacement can be, please tell me, displacement can be zero? Yes or no? It can be zero, na? It can
Yes,
be
sir.
positive or
Negative.
clear or not. So even though the particle is moving, even though the particle goes moved for some distance, it travel for some time, but still it is possible that its displacement can be zero if it come back to the same point. It may be positive if it travels in the positive direction of the x-axis or y-axis or z-axis like that, or it may be negative also. If the final point is other side of the positive axis, then the displacement will be what? Negative, isn't it? But now tell me about the distance. For a moving particle, can I say distance is, tell me, always
Positive.
what? Always
Always
some
positive.
positive value. Understood? So if a particle has traveled If a particle has traveled for some time, then its distance is always going to be what? Positive. It can never become zero. It can never become negative. Is that clear?
Yes, sir.
And last thing, tell me about the distance and displacement. When the distance will be equal to the magnitude of displacement?
When
When
the
can I say the distance?
travels the shortest,
When it travels in a
when it travels in the shortest path.
yes, when it travels in a straight line. If a particle is traveling in a straight line, then can I say, and a straight line also, one more thing, it travels in a straight line only in one direction. It doesn't come back. It doesn't come back. In that case, can I say that the distance will be exactly equal to the magnitude of displacement? If a particle travels in such a way that it always moves in one direction and it is not turning back, it is not turning back or it is not coming back in its own path, can we say that in that case the distance is going to be equal to the magnitude of displacement? Please tell me.
Yes, sir.
So now we are going to define about the next physical quantity, which is going to be the velocity and speed. Okay. Now you see, velocity and speed is completely dependent on what? Displacement and distance. So please tell me, do you understand about the displacement and distance first? Because velocity, if I ask you to solve it, you need the displacement concept. If I ask you the speed, you need the distance concept. Please tell me, is that clear? So
Yes,
that
sir.
next, when I will take some example, you will see that in that example, I'm going to use displacement, distance, velocity, speed, all calculation simultaneously. We will do it. Means in the single question, we will be calculating what is the displacement, distance, velocity, speed, everything. Is that clear? So now we are going to define two more physical quantity. One is called velocity, other one is the speed. Are they same or different? Velocity and speed, are they same or different?
Different type of quantity.
Different type of quantity. What is the difference between these two?
One is vector, one is scalar.
One is a vector, other one is what? A scalar. Okay, correct. So now I am going to define the velocity. What does it mean by velocity and how many ways I can define the velocity? Please tell me.
The distance traveled by in a particular time is on a speed. Its displacement traveled in a particular time.
Is velocity correct? So tell me, velocity, can I define it in a two way? Can you tell me what are the two way? First type of velocity I'm going to call is the average velocity. Okay, first is what? Average velocity. And the second one is what? Can you answer it? What is going to be the second one?
Instantaneous velocity.
Instantaneous velocity. Instantaneous velocity. What is the difference between average velocity and instantaneous velocity?
Average is the total distance covered in total time period, whereas instantaneous is in a very short amount of time, small interval.
Total distance or total displacement? Now you
Total
have to be very
displacement.
careful. Yeah, because I will give you some question and ask you to calculate average velocity. Sometimes the question will ask average speed. So these two are two different quantity. Okay. See, a simple difference in average and instantaneous is what? Average is a large time interval, big time interval. Instantaneous is what? If the time interval keep on reducing so that it becomes a instant. Instant is what? Microsecond, millisecond, like that. So then that moment, at a moment what we have the velocity, that's called the instantaneous velocity. Okay. So how do we calculate the average velocity? Please tell me. So average velocity is what? It is the total displacement of the particle. What is the average velocity? It's a total displacement. Displacement is a vector quantity by what? Total time taken for completing that displacement. Is that clear? So what makes velocity to be a vector? What makes velocity to be a vector? It's a displacement, isn't it? Why? Because total displacement is a vector quantity, time is a scalar quantity, isn't it?
Yes, sir.
And instantaneous velocity means you can also write it like what? Displacement by time taken,
dx by dt.
right? Now, what is going to be instantaneous velocity? So instantaneous velocity means what? If a small time interval, how do we write mathematically? So small time interval, we write mathematically dt. Delta t is a big time interval. Dt is what? A small time interval, okay? So when we do dx by dt, that means it is called the rate of change of position, or it is also called as the rate of change of displacement, okay? So that gives us what? The instantaneous velocity. Is that clear? Please tell me. Average velocity and instantaneous velocity.
Sir.
Is that clear? Yeah, please
Yes,
tell me.
sir.
Please tell me. Any
Clear,
confusion?
sir.
Right. Again, average velocity for a moving particle, can it be zero, positive, negative? Please tell me.
Yes, sir. It can be.
Right. And same way, instantaneous velocity can be also positive, zero, or negative. Is that clear? So in a vector, positive and negative tells us the direction. And what is the value gives us the magnitude. Is that clear?
Yes, sir.
Now we have the speed. What is the speed? Tell me, what kind of quantity is the speed?
Scalar.
Scalar quantity. How many ways we can define the speed? Please tell me.
Average and instantaneous speed.
Very good. We can define it by what? Average speed. And the second one is what? Is the instantaneous speed. Okay. So now please tell me, what is the average speed?
Total distance traveled. Total time.
Total distance traveled by the particle. Okay. What is that? Total distance traveled by the particle divided by what? Total time taken to cover that distance. And what is the instantaneous speed? So instantaneous speed, you know what is that? It is the magnitude of instantaneous velocity. Instantaneous speed is what? It is just the magnitude of instantaneous velocity. Understood? Why? Let me tell you. See, when you are traveling in a vehicle, do you look at the speedometer? Please tell me. Do you look at the speedometer sometime? Does the speedometer reading is always constant or will it keep on changing?
Keeps on changing.
Keeps on changing, isn't it? The moment you look at the speedometer, you look at in front of the road, you again look at the speedometer, you will see the reading will change. Na? Nowadays, digital speedometer is there, isn't it?
Yes.
So that much frequently the velocity of the body or the vehicle is changing. Now tell me, if I look at the speedometer, it showed me something 40 kilometer per hour. So if I say the reading of a speedometer is 40 kilometer per hour, actually what I am telling right now, Am I telling the speed of the vehicle at that moment?
Yes.
But at the same time, let's say a modified form of speedometer is there. Maybe in next few year you will get that kind of. Earlier we had the analog speedometer, na? 10, 20, 30, 40 like that, right? Please tell me. Earlier in the vehicle we had
Yes,
na
sir.
speedometer. That's called analog, that needle one, right? So 10, 20, 30, right? Now last 5 year, 10 year digital came where it shows 10, 11, 12 like that, है ना? Let's say next 5 year an automobile company wants to do something else, right? Just they want to bring a product here. Although there is no use of that one, what did they do? They just fit a compass also in the speedometer. Possible, na?
Mm.
Please tell me. They can fit a compass in the speedometer. Now it will also represent 40 kilometer per hour north east 65 degree, right? Something like that is showing in the screen. Now tell me, if I only tell you this part, if I only tell you this part, let me hide this one. Okay, I have hidden this one. Tell me what I am telling you. If I hid this one, only 40 kilometer per hour, that is
Instantaneous
the
speed.
instantaneous speed. At that moment, what is the reading of the speedometer? But the moment with this speed, I put the direction as well. Now it become together what?
Instantaneous
Together it
velocity.
becomes the velocity, instantaneous velocity. Is that clear? So that's why instantaneous speed is nothing a new thing. There is no separate method to calculate the instantaneous speed. Whatever is the instantaneous velocity we have, we should just tell the magnitude of instantaneous velocity and it become what? It becomes the instantaneous speed. Is that clear? Now again, can I say that average speed is, tell me, average speed is always going to be the more than the average velocity, magnitude of average velocity, isn't it? Just like here what I have written for the displacement and distance.
Yes, sir.
Please tell. Clear? Now, one last thing we are going to define, and then we will discuss many question on that one. Okay. Last thing. Tell me, what is the last thing we are going to define? You please tell me.
Acceleration.
Acceleration. So we have total how many quantity in the physics? In the first kinematics chapter, position. Position gives us idea about the displacement. So we have two physical quantity, displacement and distance. One is scalar, one vector. Next, two physical quantity which measures the change in position with time, but in a different way. One in a scalar way, another one in a vector way. We have speed and velocity. But again, velocity we can define it for large interval as average, small interval as instantaneous. Clear? Same way, speed also average and the instantaneous. So now the last thing, let's define it, is called acceleration. What is the acceleration? Scalar or vector?
Vector. Vector.
It is a vector. So please tell me how many ways we can define the acceleration. Now you can guess it and tell me.
Two. Average and
Yes. First one is going to be the average acceleration. Second one is going to be what? Instantaneous acceleration. What is the difference between these two? Again, is it the difference of time interval? Average case,
yes.
time interval is large. So what is, Acha, can you tell me what is the purpose of acceleration? What acceleration does actually? Tell me what acceleration does actually. Please tell me. What do the acceleration do? what acceleration does?
It accelerates things.
It accelerates things. Very good. Any other answer? So what does it mean by acceleration? When I can say someone is
Change in speed.
accelerating, change in
Speed.
speed. Okay, that's it. When I can say someone is accelerating, see, acceleration changes speed. It's a 50% correct. But if you say acceleration changes velocity, that's 100% correct, isn't it? So acceleration has the purpose of changing the velocity. Now, if you want to change the velocity, you have the two options. What are the two options? You change the speed, velocity got changed. Correct? Please tell me. I want to change the velocity. What I did? I just changed the magnitude of velocity. I said, yes, velocity got changed. We have the acceleration. Or else what? Let me just change the direction, isn't it? Because velocity, I want to change it. I did not change the magnitude. I just changed the direction of the velocity. I changed the path in which it was moving. It is still the change in velocity, isn't it? So that means what acceleration does, it changes the velocity. Is that clear? A different type of acceleration will come when we go to the next chapter, like centripetal acceleration, tangential acceleration. A different type of acceleration has a different role. But what is the single line about acceleration? It changes the velocity. The moment I say the particle has acceleration, its velocity must have been changing. Understood? Please tell me. So, average acceleration will be what?
Initial
Change in
speed minus
velocity.
final speed.
No, no, no. Tell me velocity, velocity.
That's what.
Velocity and speed is different,
Yes, sir.
right
Yes.
or not?
Yes.
Now you are not telling that because when the question will come, you will see that a small, small change, whether you are finding the change in velocity or you are finding the change in uh, speed, it will make a different answer. I will just give you one simple example, okay? Change in velocity by what? Total time taken, okay? And instantaneous acceleration, again, instantaneous means the time interval is small, that means the dt. So I should take help of what? That rate of change of what? The velocity, isn't it? That is what we should use it. See, let me just ask you a simple question, okay? Very, very simple question. I'm saying a particle velocity is right now 5 I cap, and after some time its velocity becomes 5 j cap. Please tell me, this is the initial velocity, this is the final velocity. Can you tell me, is there change in speed? Please tell me, is there change in speed? Listen my question carefully. Is there any change in speed?
No, sir.
No. But is there change in velocity?
Yes, sir.
Right? So does it have acceleration or not?
No.
Uh-huh. Change in velocity is there, so definitely the
Yeah,
acceleration
yeah,
will
yeah.
have,
It's
na?
there.
Please tell me, all of you, please respond.
Yes, sir. It's there.
Yes, sir.
Understood? So that's why it is important. That's why I am writing step by step. Change in velocity, and we are highlighting here also. I am talking about change in velocity, not change in speed. Acceleration is for what purpose? For changing the velocity purpose. So if the velocity changing, there will be acceleration. Okay, is that clear?
Yes, sir.
Now, let me take an example where I'm going to give you all the idea about whatever. Here they will give you in the question what is the time taken for that change happen. then you can calculate the change in velocity. Okay. And the time taken, if you divide it, it becomes the acceleration. Let me take an example and try to understand what I just discussed with you. Okay. In this example, let's say a circular path is given to us. Okay. A circular path is given to us. A particle is initially here. Okay. Where is the particle? Particle is initially at this point. And after some time t, the particle goes here. Okay, understood? Particle goes from I to F. This is the center of the circle. And how the particle went? The particle went following this path. Understood? Particle went along the arc of the circle. Clear? Along the circumference it is traveling. Particle is traveling how? It is traveling along its circumference. Radius of the circle is given to us as 5 centimeter. Please tell me a few things here. Find displacement of the particle. I'm going to write few things what we have to calculate here. Find displacement. Just right now, tell me the magnitude of displacement. That is enough. I will tell you about the direction also, don't worry. Second thing, find the distance traveled by the particle. Okay. Third thing, the question gave time taken by particle. Question also gave time taken by particle to go from initial to final point is 4 seconds. Okay. How much time the particle took to go from I to F? 4 seconds. So now find it. Average velocity. Okay. In this journey, find the average velocity. Fourth thing, average speed. Average is the average acceleration also. But let's keep it for the next part. We have to discuss many questions on this definition of the displacement, velocity, these things. So please tell me first, what is going to be the displacement? How do we calculate the displacement? Please tell me, all of you. What does it mean by displacement? Does the path shortest distance? Yes. Does the path is important for calculation of displacement?
No, sir.
No. Only what is important for displacement?
The distance, the shortest distance initial and final.
And is that distance is nothing but the straight line distance? Please tell me.
Yes, sir.
So it means to calculate the displacement, what should I do it? Should I just join the initial and final point by a straight line?
Yes, sir.
So what is that a straight line? Let's call it C, let's call it A, and let's call it B. Is that AB length going to give me the displacement? Tell me.
Yes, sir.
So magnitude of displacement, is that going to be the length of AB? Straight line length AB. Please tell me
Pi root 2.
how much is that? Is it
Pi root
equal
2.
to R? And is it equal to R? Is it root 2R? And radius is given as 5 centimeter. So 5 root 2 centimeter, we got it. Now please tell me, what is the distance?
Pi by 2.
Now tell me. Yes. Tell me, distance depends on the path or not? All of you, please tell me. Does the distance depend on the path? Yes.
Yes,
What
sir.
path the particle followed? What path the particle
Along the
follows?
circumference.
Along the circumference. Is it equal to is the distance is going to be arc length?
Yes, sir. Equal to r theta.
And is that arc length r into theta, isn't it? So r into what is the theta? Pi by 2, na? 90
Pi by
degrees
2.
also called as pi by 2 radian. So r into pi by 2. So 5 pi by 2 centimeter. Now tell me, what is going to be average velocity here?
Pi by 2 root 2.
Right? What is going to be average velocity? Just tell me the
Pi by 2
magnitude.
root 2.
Okay, now direction I will discuss. So how much it will come? 5 root 2 is the displacement magnitude. It has taken 4 seconds to reach there. Can I write it 5 by 2 root 2? Right now, root 2 by 4 is there, isn't it? We can write it now, 2 root 2. And what is the last thing? Average speed. Please tell me, what is pi by 2 is the distance and time is 4 seconds. So am I getting 5 pi by? Are you clear about these 4 things we have discussed in this question?
Yes, sir.
Please tell me, understood this one now? So this
Yes,
is
sir.
about the average velocity, average speed, displacement, distance. Today I just took it one question. Okay, don't worry, I will discuss it. Many questions, okay? All type
Yes,
of
sir.
questions we are going to discuss. Just before finishing, tell me a last question. Yeah, please tell me.
Nothing, sir.
Question gave initial point of a particle is given 2 comma 3 comma minus 1, and finally the particle goes to minus 6 comma 3 comma 2. Can you find the displacement of the particle?
Yes, sir.
How? Tell me. So here, if I
Vectors
want the displacement,
minus 8, 0,
what
3
is going
volts.
to be the displacement here? So should we right? So what we should do is to find the displacement. Should I first find out what is initial position vector? The coordinate is given. Can I convert coordinate into vector form? So 2, 3, minus 1. So in the vector form, what I can write it? Can I write it in the vector form 2 cap, right? J component 3, so 3 cap. K component minus 1. So can we write it? It is going to be 2 cap plus 3 cap minus k cap. Tell me. Initial vector, initial position vector. Can we write it? It's going to be 2 cap plus 3 cap minus k cap.
Yes, sir.
Coordinate we have converted into what? The vector form. And what is going to be the final position vector? So minus 6 cap plus 3 cap plus 2 k cap. So now we want the displacement vector. Final position vector minus initial position vector. Actually, subtract it. So if I subtract it, I'm getting minus 6 minus 2 minus 8 I
Minus 8,
cap 3 3. Okay, so that's
0
gone. 0 j cap
plus 3k.
and 2 minus of minus 1. So 3 k cap. This must be. So this is the displacement vector. What is the displacement vector? Minus 8 I cap plus 3 k cap. If someone asks you what is the magnitude, can I write it? I cap
Under root
component
64 plus.
square, j cap 0, k cap this one. Understood? So 64 9 root 73 will be there. Whatever unit is given in the question, that unit we will use it. So please tell me, understood what we discussed today?
Yes, sir.
So please today what will be your work? you have to complete electrostatics, all the question given. That is the first thing. Second thing, whatever we have discussed, go through the notes once, right? Okay. Any reference book you have, read those reference books if you wish. And Wednesday we will have the next class on the mechanics. So Wednesday we are going to discuss all type of questions here based on what the displacement, velocity, average velocity, these calculation, and then we will go for what the uniform acceleration part, equation of motion. Okay, I hope it's clear now. Please tell me, anyone have any confusion or doubt? Please
Yes,
ask
sir.
it now.
Nothing, sir.
So I will share the notes with you. Please tell me, is that clear what we discussed till now? Right? So let's meet it on the Wednesday now. Okay.
Okay, sir. Thank you, sir.
Thank you so much. And please complete those two things. Okay. Electrostatics, all the questions, and go through what we have discussed in the mechanics part, so that next class when we will discuss questions, you will be very much clear about what we are using now.
Okay, sir.
Take care, everyone. Good night.